Okay, in this lesson we're going to be looking at Unit 6, Chapter 6, Trigonometric Identities again. And now we're looking at Reciprocal, Quotient, and Pythagorean Identities, Part 3. And we're going to look specifically at using the identities to simplify expressions. So again, the focus is simply going to be on using those three types of identities that I just mentioned on simplifying expressions. Let's quickly review what those identities are again: the Pythagorean identities, the reciprocal identities, and the quotient identities. Pythagorean identities are sine squared plus cosine squared equals 1. Cotangent squared x plus 1 equals cosecant squared x. And tan squared plus 1 equals secant squared. Now from each of these three, of course, there are other identities, I suppose, that we can develop. And they are very simple. Let's quickly review what they are. If sine squared x plus cosine squared x equals 1, then clearly sine squared x is equal to 1 minus cosine squared x. And as well, cosine squared x is equal to 1 minus sine squared x. And all I simply did there is I took this equation I solved for sine squared, bring the cosine squared to the other side, subtract. And I've taken this equation and I've solved it for cosine squared by bringing sine squared to the other side. So these are two identities that follow directly from the Pythagorean identity sine squared x plus cosine squared x equals 1. I left it the x there. These are just as important, and you need to be able to recognize these just as much as you need to recognize this one here. In a similar way, we can take the other two Pythagorean identities, cotangent squared x plus 1 equals cosecant squared x. If we were to solve this one for cotangent squared x, we would get cosecant squared x subtract 1. And in a similar way, tan squared x plus 1 equals secant squared x. Tan squared x, solving for tan squared x, equals secant squared x, subtract 1. So it's important that you not only recognize these identities, but also the identities that follow directly from them. Cotangent squared equals cosecant squared minus 1. Tan squared is equal to secant squared minus 1. I want you to notice that each of these identities that I've written here are all identities that can be factored simply using the difference of two squares. This one, oops, sorry, let me put a box around the other two as well. This one, and this one. I can actually factor the right side of all of these equations. 1 minus cosine squared is the difference of two squares, is 1 minus cosine times 1 plus cosine. 1 minus sine squared can be factored as 1 minus sine times 1 plus sine. Cosecant squared x subtract 1 can be factored. Cosecant subtract 1 times cosecant x plus 1. And the same thing here, difference of two squares. Secant squared x subtract 1 can be factored as secant x subtract 1 times secant x plus 1. Just something to recognize here with each of these identities as well. The Pythagorean identities are the ones we just looked at. The reciprocal identities are, and again you should know these, cosecant x equals 1 over sine. Secant x equals 1 over cosine. Cotangent x equals 1 over tan x. The quotient identities are simply tan x equals sine x over cosine x, and cotangent x equals cosine x over sine x. So as a quick review of the identities, now let's learn how to simplify expressions using these identities. Let's have a look at the first example here. Simplify the expression. Cotangent x divided by cosecant x times cosine x. So we want to simplify this. Cotangent x, recognizing cotangent is equal to cosine over sine, so I'm going to rewrite this as cosine x over sine x divided by, again we're going to rewrite cosecant as 1 over sine times cosine. This will give me cosine x over sine x divided by, now we need to multiply this together in my denominator, 1 over sine times cosine is cosine over sine. Now you should be able to recognize immediately that this is equal to 1 because I got in the numerator cosine divided by sine, in the denominator I got cosine divided by sine, and again you should recognize anything divided by itself is equal to 1. If you didn't recognize that, of course, you could have put in an extra step here and actually done this. Cosine x over sine x divided by cosine x over sine x multiplied by the reciprocal That's how we divide fractions. And then you would have seen, hopefully, that the sine x's cancel, the cosine x's cancel, and you're simply left with, as we said, 1. There's another way we could have looked at it. So again, we took the expression, we converted everything back to sine and cosine. That's one of the strategies for simplifying expressions. Change everything back to sine and cosine. When we did that, we see that it equaled 1. Example 2, simplify this expression. Again, we use the same strategy. Convert everything back to sine and cosine. So secant is equal to 1 over cosine. And I guess I better use theta here. Subtract sine theta times tan, which is sine over cosine. So I'm going to write that as sine theta over cosine theta. Now, if you look closely at what I have in the brackets here, this can be simplified, and I get 1 over cosine theta, subtract sine squared theta over cosine theta. When I write this with one nice denominator of cosine theta, because I do have the same denominator here, 1 over cosine subtract sine squared over cosine, I already have a common denominator, so I can write this as one nice denominator of cosine theta. My numerator is 1 minus sine squared. 1 minus sine squared, remember, from what I just covered a couple of pages back, 1 minus sine squared is equal to cosine squared. So I'm going to rewrite my 1 minus sine squared as cosine squared over cosine theta. Cosine squared divided by cosine is cosine theta. So I've simplified the expression to simply being equal to cosine theta. A couple of things I had to do there. I wrote everything back in terms of sine and cosine, and I also had to recognize the identity 1 minus sine squared is equal to cosine squared. That was a very important part. Next example, simplify this expression to one of the three primary trig ratios. So I want to write this one as a primary trig ratio, which is sine, cosine, or tan. So let's see if we can do that. Again, I'm going to write everything back in terms of sine and cosine. Cosecant is 1 over sine. Tan is sine over cosine. Cotan is cosine over sine. In my denominator, I have two fractions that are added. I need to add these two fractions. In order to add these two fractions, I need to get a common denominator, or I need to write both of them with the same denominator. My common denominator between cosine x and sine x is cosine x times sine x. So if I want to write this fraction with a denominator of cosine x times sine x, I need to write this fraction, or I need to rewrite this fraction by multiplying numerator and denominator by sine x. This will give me a denominator of cosine x times sine x is an equivalent fraction. Cosine x, sine x, and my numerator now, of course, is sine times sine, which is sine squared. Plus, in a similar way, if I want to write my second fraction with a denominator of sine x, cosine x, I need to write an equivalent fraction by multiplying this one by cosine x over cosine x, of course. Now you see that I end up with sine x, cosine x, and my numerator here becomes cosine squared x. But the good news is that I now have the common denominator of cosine x times sine x, and I can actually add these now because I do have the same denominator. I couldn't do that before because I didn't have like denominators. So I had to create like denominators by, again, multiplying this fraction by sine over sine, which of course is 1, multiply this fraction by cosine over cosine, which again is 1. I'm not changing the expression because I'm only multiplying by 1. Let's see what I get. I get 1 over sine x divided by, let's rewrite this as sine x times cosine x. Let me just get rid of that. One nice denominator, I get my numerator becomes sine squared x plus cosine squared x. We should recognize at this point that sine squared plus cosine squared in my numerator here equals 1, using my Pythagorean identity. So now I'm going to rewrite this as 1 over sine x divided by 1 over sine x cosine x. Let's divide. We end up with 1 over sine x divided by 1 over sine x cosine x, which becomes 1 over sine x times cosine x sine x over 1, multiplied by the reciprocal, of course. This sine x will cancel with this sine x. And I'm left with simply cosine x. It did say to simplify this to one of the three primary trig ratios. I did that. The primary trig ratio is cosine x. Let's have a look at another example. Here's a multiple choice question for you. You may want to try this one on your own before I actually do it, now that you've seen a few of these done. So if you want to pause the recording, you can do that. Which expression is equivalent to sine theta plus cosine theta squared? Sine theta plus cosine theta squared. If I were to take this as squared, I would get this. Note, I do not get sine squared plus cosine squared. It's sine theta plus cosine theta times sine theta plus cosine theta. That's how I square that. I multiply it by itself. Now, I just simply use the distributive property. Sine times sine is sine squared. I've got sine times cosine. Well, I write that as sine theta cosine theta. I got cosine times sine, which again is sine theta cosine theta. And I got cosine times cosine, which is cosine squared theta. Simplifying this, I get sine squared theta plus, you should recognize this now as the same terms. I can add like terms. I will get two of these. Sine theta cosine theta plus sine theta cosine theta is 2 sine theta cosine theta plus cosine squared theta. Now you should also recognize at this point, again, our Pythagorean identity, sine squared plus cosine squared equals 1. So I simply left with 1 plus 2 sine theta cosine theta. 1 plus 2 sine theta cosine theta, correct answer is A. I can't do anything else with that. Okay, let's have a look at another example here. I've got cosecant theta subtract sine over cotan squared theta. Let's do it. Again, you may want to pause the recording at this point and try it on your own first if you wish. Cosecant is equal to 1 over sine. Subtract sine theta. I'll put that over 1 because they're subtracted. Divided by cotan squared. Cotan is equal to cosine over sine. So it's cosine squared over sine squared theta. Now again, I need to try and simplify this. So let's do that. We're going to take our numerator, and again, we need to create a common denominator. The common denominator in this case is sine theta. That doesn't change my first fraction. My second fraction, though, I need to create a denominator of sine theta. In order to do that, I had to multiply my denominator by sine theta and my numerator by sine theta. So sine times sine is sine squared theta. Divided by cosine squared theta over sine squared theta. My numerator now works out to be pretty nice because I end up with a denominator of sine theta. My numerator is 1 minus sine squared theta. Divided by cosine squared theta over sine squared theta. Again, you've got to recognize that 1 minus sine squared is equal to cosine squared. So this now becomes cosine squared theta over sine theta divided by, or in other words, multiplied by the reciprocal. Just trying to skip a little step here. Sine squared theta over cosine squared theta. Everyone should follow that. The cosine squares will cancel. One of these signs will cancel one of these signs, and I'm simply left with sine theta. Final answer is D, sine theta. But I had to do my numerator first before I do any division because I'm subtracting my numerator there. I had to do that first. Last example, simplify completely. Minus sine squared x over cosine x subtract 1. Note the numerator is minus sine squared. All I can really do here, because everything is already in terms of sine and cosine, I can't write anything back. But maybe I can replace sine squared with something. I know that sine squared theta is equal to 1 minus cosine squared theta. So therefore, minus sine squared theta is equal to the negative of that, which will give me a -1 plus cosine squared theta. Now if I rewrite that, that becomes cosine squared theta subtract 1. So let's go up and fill that in here. We got cosine squared theta subtract 1 over cosine theta, or x. Maybe I should have been using x, but I'll stick with my theta here. It doesn't really matter. Cosine theta subtract 1. My numerator does factor. It factors to cosine theta subtract 1 times cosine theta plus 1 divided by cosine theta subtract 1. The cosine theta subtract 1's will cancel, and I'm left with cosine theta plus 1, or cosine x, of course. So the correct answer is B. The only issue I really have here is the fact that I started my cosine squared x and I call it cosine squared theta. Doesn't really matter, of course. But you see that I had to rewrite that as 1 minus cosine squared. So a negative sine squared is simply the negative of that. So if I multiply the -1 in through, I get a -1 plus cosine squared. Rewriting that by putting the cosine squared first, you see I actually get the difference of 2 squares. And I took that and I factored it. And then those two canceled, and I'm simply left with cosine theta plus 1. Okay, key ideas. You can use trigonometric identities to simplify more complicated trigonometric expressions. The reciprocal identities are cosecant x equals 1 over sine, secant x equals 1 over cosine, cotan x equals 1 over tan. The quotient identities that we used were tan x equals sine over cosine, and cotan x equals cosine x over sine x. And of course, the Pythagorean identities were cosine squared x plus sine squared x equals 1. We used that one a fair bit. We didn't use these too much, but we will be using these more in some of the upcoming lessons. 1 plus tan squared equals secant squared, and cotan squared plus 1 equals cosecant squared. And that ends this lesson.